We are talking about rationalizing denominators when we have an I in there. So let's just start off with an easy one like 3 over I. So rationalizing denominators. So, ladies and gentlemen, remember that I'm not allowed to have a square root in the denominator, which is what I have right here. I is square root of -1, so I can't leave it there. So, do you remember how you handle it if I had something like this? 3 over the square root of 2. I multiply by square root of 2 over square root of 2, which is just 1, but then that gets rid of the square root in the denominator, okay? I use the same exact idea here, so I'm going to multiply by I over I. I over I is still just 1. Just I. Yep, just I over I. Because watch what happens. When you multiply across the top, 3 times I is just 3I. I times I is I squared, but I squared is just -1. So my final answer actually just comes out to be -3i. So if I have an I in the denominator, that's how I can handle it. Just multiply by I over I. Yep. Sure, why not? Let's wait until the bell has already rung and we've already begun, and now's a great time to go. All right. Let's try another example. How about, what if you had something like 4 over 5i? Is there anything with having a 5 in the denominator? No, you can have a 5 down there all day long. It's the I that we have the problem with. So, it's not a mistake, but you're doing too much. You don't have to multiply by 5i over 5i, because the 5's not the issue. I can still just multiply by I over I. Get what I'm saying? I don't have to do 5i over 5i. You can, but why make your situation harder than it has to be? So I just multiply by I over I. Look what happens. Up top I get 4i. What's my denominator become? -5. And I'm all set. I don't have any square roots in my denominator, so everything's fine. What happens if you have something like this? Yeah. Here's a common... Yes. Look at you go. There's a very common error that I don't want you to make. You can't cancel out those 2 i's. It doesn't work like that because he's part of a binomial. If it was multiplication, you could. So for example, if you had 2i over 3i, yes, the i's cancel. But if you have 2 plus I over 3i, that's part of a binomial. You can't cancel out a piece of a binomial with something else that's not in a binomial. The only thing I could do is if I had another 2 plus I down here and I canceled the whole thing with the whole thing. Okay, so that's a common mistake. You cannot cancel those out. But I can multiply by I over I, just like he said. When I do it in the numerator, you have to distribute. You're going to have I times both of those items. So now I really get 2i plus I squared. In the denominator, that's 3i squared, so that's really -3. But I'm still not done because I squared is really -1. So I'm going to have -1 plus 2i all over -3. I just moved the -1 to the front because remember you always want the I on the end. Does that make sense? So try this one. How about try to rationalize that denominator. Okay, we got an answer? Maybe? Or a first step? How about that? Manny, what would I do first? You have an answer?
Yeah.
All right, tell me.
5 plus 4i over negative 2.
Isn't 4i plus 1?
Does it matter if the 5 and the 4i comes first?
Mathematically, no. But the form you want to be in is having the I on the end. So that's the habit you want to get into.
Once we deduct it on the test, if we do it the other way.
I mean, no, but it's not in the right form. It's almost like starting a sentence with a lowercase letter. You know what I mean? It's still the same word, but it's not the right form. So, yes, I would multiply as still by I over I. You don't have to do 2i over 2i. If you do 2i over 2i, what ends up happening is you just have to reduce more stuff later on. So you're making more work for yourself. Don't do that. Up top, I have to distribute 4i minus 5i squared. Denominator 2i squared. And now let's just change our I squareds into negatives. So that I squared becomes negative 1. So now it's a positive 5. So I want 5 in the front and the I on the end. Down here, that's going to get me a negative 2. That's a good answer. All right. Let me try and stump you. How in the world would you handle this? Go ahead.
Would it be 2i over 2?
The final answer? I have no idea what the final answer is. I can't do that amount of work in my head. Which is a hint that there's an amount of work that needs to be done. Here's the problem. You can't just multiply by I over I here. The goal is to get rid of I in the denominator, right? If you multiply by I over I, when you multiply the denominator by I, that I will go away, but didn't you just make a 3i? Right? If I multiply, watch, I'll do it. If I multiply by I over I times I over I, you get 2i over 3i plus I squared, so that's a minus 1. I'm no better off. I still have an I in the denominator.
So would you multiply by 3 plus I?
Great thought. So let's try that. I need another sheet of paper. So we had 2 over 3 plus I. So Philip's idea is let's multiply by 3 plus I over 3 plus I. Let's see what happens. You don't have to write this down yet. Let's see what happens. If I multiply by 3 plus I over 3 plus I. So up top, I'm just going to distribute the 2. So it'll be 6 plus 2i. Agreed? On the bottom, that's a binomial times a binomial, so I'm going to have to FOIL that together. So first, outside plus 3i, inside plus 3i, last plus I squared. So that's a negative 1. So I get 8 plus 6i. Am I any better off? I still have an I in the denominator. No, we're actually super close. Look at what happened. This I squared did go away, right? Yeah.
Would you multiply by 3 minus I?
Yes. It's called the complex conjugate. When you were doing this with square roots, do you remember that word conjugate? Yeah, when you have a binomial. See right here, that 3i plus 3i? If one of those had been negative, they would have canceled each other out. And then the i's would have been gone, because that I squared turns into a negative 1. So what we need to do is not multiply by 3 plus I. It's got to be you got to change the sign in the middle. Okay? So that's called multiplying by the complex conjugate. So let's try that. So if I had 3 plus I, so there's my original. But now we're going to multiply by 3 minus I on top and bottom. So it's the exact same binomial. I just changed the sign in the middle. This should work. So across the top, 6 minus 2i on the bottom. So FOIL. First, outside, inside, and then last is going to be a minus I squared. But see how nice this is? The minus 3i and the plus 3i cancel each other out. Be careful with this though. What is this whole chunk now? Positive 1, because I squared is negative 1 and I'm minusing it, so negative negative 1. This whole thing is now a positive 1, so that means my denominator is now 10. See how that worked? So I am better off now. I don't have any i's in the denominator. Let me ask you this question. Is this a good final answer? 6 minus 2i all over 10. No. Why not? Yes. The 6 and the 10, you say?
Yeah.
Oh, yeah. You can't simplify just a piece of a binomial with something else. What I can do is I can factor a 2 out of the top. And if I take out a 2, then I can reduce the 2 with the 10. Because I'm going to turn it into multiplication. Watch. So I'm going to factor a 2 out of the top, and that would leave me with 3 minus I. Now, that 2 is not part of a binomial anymore, so the 2 and the 10, I can absolutely reduce with each other. So now I get 3 minus I over 5. And there's my final answer. No radicals in the denominator, so we're happy. Let's try another one like this. And I'll let you give it a shot before I tell you what to do. How about, let's throw a negative up top. How about negative 4 over, I don't know, 3, oh, I just did 3. How about 8 minus I? Try and rationalize that one for me, please. Please make sure that your final answer is totally simplified. So no square roots in the denominator, no common factors between the top and the bottom. Okay, you got something? Let's try it. So, what am I multiplying by this time? Yes, 8 plus I, the conjugate of what's already there, okay? So, across the top, negative 32 minus 4I. And on the bottom, we got a FOIL. 64 plus 8I minus 8I minus I squared. So the 8i's cancel. That whole thing turns into a plus 1. So I get a 65 in the denominator. Do I have any common factors between, so from the top I could factor out a 4, but I can't reduce it with anything in the 65, so I don't really need to bother, right? There's no common factor between the top and the bottom. Do you agree? Yeah, so you're done. You can leave it like this. If you factored out the 4, doesn't matter. So you could have left it as negative 4 and then 8 plus I in there over 65. Either way, it's the same thing. But since I can't reduce 4 with 65, I didn't have to do this. Okay, so there's only one way that these get a teensy bit harder. So if you looked at the ones that we've done, when you have a binomial in the denominator, I've been nice and been leaving the numerator as a monomial. They're not always going to be that way. So what if you had a binomial over binomial? Woo, doggies. Okay, say you had, we'll keep them small. How about like 2 plus I over, I don't know, 5 minus 2I. Whoa. Okay, so say I'm here. How are you going to start? Yeah, I'm going to start by multiplying by 5 plus 2I on the top and bottom. The only difference this time is that the top and bottom both need to be FOILed, right? Because they're both binomial times binomial. So take a moment and FOIL your numerators together. And see if we agree. And then go ahead and with your denominators. What do you say? Did you get what I got? Do we all agree? Yeah, you sure? So I FOILed the top together, combined my like terms. 2I squared, remember that's going to turn into a negative 2, so negative 2 and 10 got me the 8, 4I and 5I, 9I. Downstairs, I'm expecting all the i's to cancel out. First, 25, and then when you do outside, you're going to get a positive 10I inside negative 10I. So that did cancel, and then my last, negative 4I squared. I squared is really negative 1, so that turns out into a plus 4. 25 plus 4 gets me the 29. Is this a fully simplified answer? 8 plus 9I over 29. Yeah, I can't do anything else. So that's as hard as these get. The only thing that I want to show you that sometimes throws kids for a loop, I don't know, say you had like 2 over negative 3 plus 4I. What's your conjugate here? What would you multiply by? Yes, that sign, the first one, doesn't change. It's only the sign in the middle that changes. So you don't change that to a positive. Only change the middle sign for your conjugate. So it would still be negative 3 minus 4i, top and bottom. Okay? So just remember to get the conjugate, you only change the operation in the middle from addition to subtraction or vice versa. But, right? Because when it was positive, I didn't just make that first number negative all of a sudden. So you leave all the signs alone except the one in the middle. Okay, so we can rationalize denominators? Do you remember doing it with square roots? Some yes, some no. Okay. It's the same concept, it's just you're dealing with i's now instead.